It says complete the table to show the total distance walked in each case. Now, it says Jada's pet turtle walked 10 feet and then half that length again. Okay, so let's do some quick annotations, all right? So if you notice that the 10 feet is right here and 10 is right here, that's the initial distance. But what does it mean to walk half of that length again? Half of that length again. First of all, what's half of 10? Half of 10 is 5, right? Because how do I know that we're asking for half of 10? How do you think I knew that they were asking for half of 10? If they said half of that length is 10, and they said do it again. So if I had to find out what's the total distance, well, it would be 10 plus 5. 10 plus 5 is 15. And I'm sorry about that, guys. 10 plus 5 is 15. Okay? Now let's look at part B. Part B said Jada's baby brother walked 3 feet and then half that length again. So walk 3 feet and then half of that length again. So we need to figure out what's half of 3. If you don't know what's half of 3, you could always divide it by 2. And it should give you 1.5. Okay? So when I add those two numbers together, 3 and 1.5, it should give me 4 and 5/10 or 4.5. So then it said Jada's hamster walked 4.5 feet and then half of that length. So same thing applies. I want to divide by 2. How many times could 2 go into 4? 4 times. 2 times. I apologize about that. And then how many times can 2 go into 5? 2 can go into 5. 2 times again. And then we have 1 left. We're going to add a 0 and drop it. And it's going to be 5. So half of 4.5 is 2 and 25 So I want to add this to 4.5, which would give me 6 and 75 hundredths. Okay? So then for the next one, you will say, okay, Jada's robot walked 1 foot and then half of that length again. So for 1, what's half of 1? If you guess 1/2 or 0.5, you are absolutely correct. So it'll be 1 and 5/10, 1.5 or 1.5. Okay? So then the next one, it says a person walked X feet and then half of that length again. Now I'm going to save this one. Okay? I'm saving that one for question 3. But I want us to look at question 2. It said, explain how you computed the total distance in each case. Now, how we computed the total distance in each case is, right, we had to divide, and I'm going to write this down. We added, okay, I got this. We divided our initial distance by 2, and then added our quotient, which a quotient is the answer to a division problem, So we divided our initial distance by 2 and then added our quotient to our initial distance to find the total distance. Okay, let me proofread that. We divided our initial distance by 2 and then added our quotient to our initial distance to find the total distance. Okay, so basically what we did was when it said half, we knew to divide by 2 or multiply by 1/2, which is the multiplicative inverse. And then we knew to add our quotient, or the answer that we got, to the initial distance in order to figure out the total distance. So for example, 10 divided by 2 was 5. Then we added 5 to 10, and 5 plus 10 is 15. Okay? So then it said two students wrote each equation to represent the relationship between the initial distance walked x and the total distance walked y. May wrote y equals x plus 1/2 x. And Kyron wrote y and 3/2 plus times x. Do you agree with either one of them? All right. So let's look at this, right? What we did was that we took half of the x, and just think about it. To figure out the total distance, we took x divided by 2, correct? And then we added it to our initial. Remember, x is the initial distance, right? Now, my equation looks different than both of theirs, right? But here's the reason why, okay? Whenever you have a fraction, x, or let me go do this instead, because I don't want to confuse you guys, right? We divided by 2. We said dividing by 2 is the same as multiplying by 1/2, correct? So isn't that May's equation? When we dividing by 2 is the same by multiplying by 1/2. If you guess yes, you are absolutely correct, right? So look at Karen's ones. Karen's one says 3 and 2, 3/2 x. Now, here's the reason why Karen's ones is correct. Let's look at May ones. I'm going to write May's equation down right here. X plus 1/2 x. Okay? So, what we probably didn't talk about is the number that's always understood in front of the letter x is 1. That's the number that's always understood. It's almost like, what's the purpose of saying 1x when we could just put an x to represent 1x, correct? So, I want to combine these like terms. What is a like term? Because I know you guys didn't learn about this just yet. A like term is when something has the same variables and the same amount of exponents, but we didn't get into exponents, right? But these have the same the same variable. So I could combine the two. Now they have a fraction, so what we need to do is add a 1 underneath it. When we add a 1 underneath it, we need to make sure that the fraction has the same denominators, which that would be multiplying by 2. Okay, I multiply 2 at the top and the bottom. Okay, because remember, fractions are ratios. Whatever you do to one side, you have to do to the other. So it's going to be 2 over 2x plus 1/2 x. Now I could combine the like terms, which would give me y is equal to 3/2 x. Okay, so both of their equations are considered equivalent. They're equivalent to each other. It's just that May wrote the expanded form of the equation, while Karen wrote the condensed, like the standard form of the equation, okay? So if you have any questions about this, please make sure you visit your manager's Google Meet session so they could go more into details. All right, guys, I'll see you guys in the next question. And yeah, make sure you guys check out my next video.